Today, we want to talk about one of the most iconic scenes from Star Wars. We're referring to Episode 4, when Luke Skywalker gazes at the horizon on the planet Tatooine as two suns are setting. Today's topic is it really possible for a planet to orbit around two suns? And could there be life on such a planet? We have counted over 5,000 exoplanets, which are planets orbiting stars other than the sun. But we know that these are just a tiny fraction of all the planets out there. On average, according to statistics, every star has at least one planet orbiting it. This means that there will be stars with 8, 9, 10, or who knows how many planets, and others with 0, 1, or 2. On average, though, every star has at least one planet. Therefore, there are as many stars in the universe as there are planets. In the Milky Way alone, there are hundreds of billions of stars. In the universe, there are trillions of galaxies. So we should expect that there are trillions of planets out there representing an infinity. An infinity not only of planets, but also of possibilities that these planets could have. Among all these possibilities, today we are discussing those where planets have the chance to orbit around two stars simultaneously. This question doesn't come out of nowhere because we know that about half of the stars we see in the universe are part of multiple star systems. Most, about 30% of all stars, are in binary systems. Then, 1/20th are in trinary systems. And finally, there are systems with more stars, reaching up to globular clusters or open clusters, where the stars number in the thousands. So, knowing if there can be planets in such systems, or if life could develop on these planets, is crucial for our statistics, both about the planets themselves and for the search for life in the universe. Before we continue, if you haven't already, or if this is your first time here, we invite you to subscribe to the channel and activate the bell to not miss upcoming content. We know that planets form on protoplanetary disks, which are the leftover material from star formation that flattens into a disk surrounding the young star, and this disk gathers material to form the planets. For this to happen, a stable orbit is necessary, where the material can aggregate to form the planet and has enough time to do so. Around a single, isolated star, there are many stable orbits, but in multiple star systems, this is more complicated, and even more so with more than two stars. This happens for a simple reason. If we add a star, for example, and consider two stars and a planet, we face a problem known as the three-body problem, which is physically difficult to solve because there is no simple equation like Newton's law of gravity that describes the motion of three bodies in a gravitational system. We solve this problem through numerical simulations, but we don't have a simple equation to describe it. The situation becomes even more complex with more than three bodies, such as in systems with 4, 5, 6 stars, up to stellar clusters where the stars number in the thousands, making the situation nearly unmanageable, even from the simulation perspective. The fact that stable orbits are hard to achieve doesn't mean that there are no planets, but simply that it is less likely to find them. In fact, we do find planets in very unusual situations compared to what we expect. Let's start with binary systems, because these are the ones we are interested in talking about today, and are also where we most often find planets for this reason. There are two main possibilities. The planet can orbit around one of the two stars, which is more unlikely if the stars are very far from each other, for example. So the planet manages to orbit around one of the two stars without being too disturbed by the second star. The other, more frequent possibility is that the planet orbits around both stars simultaneously. This may seem strange, but it's not actually that odd. We say that planets orbit around a star, which in turn orbits around the sun in the solar system, but that's not exactly true. The star and the planet both orbit around the center of mass of the system, which is a midpoint in space where the mass of the entire system is located. In the case of single stars, since the star has much more mass compared to the planets, this center of mass is very close to the star or even inside the star itself. In the solar system, the center of mass is just outside the surface of the sun, so saying that planets orbit around the sun is a good approximation. However, planets orbit around these centers of mass, and if we have more stars, the center of mass will be outside both, in a point in space. So it's not absurd to hypothesize that a planet orbits around the center of mass of a multiple star system. And Tatooine must actually be a planet of this type, because we see two suns of similar size setting, which implies that the planet orbits around these two stars of comparable size and at a distance comparable to the planet. But are there real planets with similar orbits around binary systems? For example, Kepler 16b was discovered in 2011, located 200 light-years from Earth in the constellation Cygnus, with the mass of Saturn and could be a gas giant. The two stars are relatively small. One has 1/3 of the solar mass and the other 1/5. The planet takes 225 Earth days to orbit around the system, so it does indeed have an orbit around two stars simultaneously. These planets are called circumbinary, and the first one discovered was in 1993, when we didn't yet have a clear understanding of having discovered exoplanets. Indeed, this planet is in the globular cluster M4 and orbited around a binary system consisting of a pulsar and a white dwarf. We confirmed that it was indeed a planet about 10 years later. It was a super Jovian with a mass 2.5 times that of Jupiter, and it was 23 astronomical units from the center of mass of the system. We have also found planets in triple star systems, 32 in total, but none of these are circumbinary, meaning they orbit around one of the stars in the system. More frequently, one star is very distant from the other two, so the planet orbits around this star while the other two act as perturbing bodies, but do not make the orbit unstable. There is, however, the case of GW Orionis, where we found a large protoplanetary disk and possibly a planet in formation, which could be the first case of a circumbinary planet, but we still need to confirm it. This disk has a very intricate and complex shape, with inclined and chaotic rings compared to those we see in protoplanetary disks. Returning to the second initial question, can there actually be habitable planets in multiple star systems? The answer is fairly straightforward. When we study exoplanets from an astrobiological perspective, the first thing we look for is whether they are within the habitable zone, which is the region of the planetary system where liquid water can exist because it is neither too close nor too far from the star. If there are two stars, it means that both contribute to the energy of the planetary system, so we need to consider both contributions to determine the habitable zone. Therefore, there is a different habitable zone compared to that of single stars, but it is still present. A 2014 study analyzed all the circumbinary planets discovered up to that point, mostly from the Kepler mission, to see what their habitable zones were like. It emerged that each star contributes its own input, and therefore the habitable zone considers both energy contributions. Of course, there are complications, such as the Serra effect. The Serra effect, through atmospheric chemistry and the interaction between stellar energy and atmospheric chemistry, can increase the temperature of the planet. So, if a planet is outside the habitable zone, it might become habitable due to the Serra effect. In this case, it is more accurate to speak of a habitable zone influenced by the atmosphere. Another issue is that different stars emit radiation differently, with peaks at different frequencies. This means that the atmosphere might respond differently depending on the energy received from the stars. It's not simply a matter of adding the light from the two stars. A more complex and less linear analysis is needed. In summary, nothing is impossible. We could find planets in the most unexpected places in the universe. It's a matter of probability. We search for places with higher chances of finding life, but it's not guaranteed that the universe will follow our expectations. Let us know if you can think of any other sci-fi stories besides Star Wars where there are multiple suns around a planet. Also, if you have any fascinating combinations for systems of this type, let us know for sci-fi narrative ideas. Thank you for staying with us up to this point. We invite you again to subscribe to the channel and activate the bell, and we'll see you in the next videos.